Today we're graphing inequalities with two variables, which is going to look like a graph of a line with a shaded area. But before we get there, we want to understand what the solutions of an inequality in two variables are. So if we look at example 1, it asks which ordered pair out of the list is not a solution of x minus 3y is less than or equal to 6. It gives you several options: 0, 0, 6, negative 1, 10, 3, and negative 1, 2. Now to check if a point is a solution of an inequality, we simply have to plug that point in. Plug in the appropriate points for x and y. So if we want to plug in 0, 0, we plug in 0 for x and 0 for y, and we see if that is a true statement for our inequality. So 0 minus 3 times 0 is 0, and that is less than or equal to 6. So 0, 0 is a solution, which means it's not an answer because we're looking for a point that's not a solution. Let's try the next point. We put in 6 for x and negative 1 for y, and we check that. Negative 3 times negative 1 is positive 3, and 6 plus 3 is 9, which is not less than or equal to 6. So 6 negative 1 is not a solution because when we plug it in, it doesn't fit our inequality. So that's how we check to see if a point is a solution of our inequality. We plug values in and see if it works. Now, as for graphing an inequality in two variables, it starts the same way we would graph an equation. We remember that when we're solving inequalities, we approach them much the same way we approach solving equations. And when we're graphing inequalities, we're going to approach them much the same way we graph equations. So the first example they give you is y is greater than 4x minus 3. We're going to treat that for a second as if it were y equals 4x minus 3. If that were the case, we would start at our y-intercept, which as we know is at negative 3, and then we would use our slope of 4 to find another point, which is a rise of 4 and a run of 1. So we'd go up 4 over 1 to find our next point. Again, up 4 and over 1 for a rise of 4, run of 1. That's our next point. So that would be how we'd graph our line y equals 4x minus 3. Since this is an inequality, however, we're going to take a couple of different steps. Now, since it's greater than and not greater than or equal to, that means that the points on my line are not actually solutions of my inequality. For instance, look at the point 0, negative 3. If I check that in my inequality and I plug in negative 3 for y and 0 for x, again, negative 3 is greater than negative 3. Is that true? No. So that point on my line is not a solution of my inequality. So since that point on the line is not a solution of the inequality, none of the points on my line are a solution of the inequality. So instead of using a solid line, since I want to keep this as a boundary line, but I don't want to look at that as a solution, I'm going to use a dotted line. Now, the easiest way I find to use a dotted line is just draw a solid line and then erase little portions there. But you can draw a dotted line down your ruler if you'd like. So we're going to use a dotted line whenever we have greater than or less than, whenever there's no equal to part of it. Now the question is, do I want the area on the left-hand side or the right-hand side? Or another way of looking at it is, do I want above the line or below the line? Now a little hint, when we're in slope-intercept form, if y is greater than, then we're looking above the line. If y is less than, we'd be looking below the line. But if we're not sure, all we need to do is pick a point on one side of the line. Let's just pick this point at random. That point is negative 2, 0. If I plug that into my inequality, is that a solution? So I plug in 0 for y and negative 2 for x. I have 0 greater than negative 8 minus 3. Is 0 greater than negative 11? Yes. So since that point is a solution, every point on that side is a solution. See, when we draw that boundary line, everything on that one side of the equation has to either be a solution or not a solution. So once we find one point as a solution, every point on this side is a solution. And so our solution is this shaded region over here, above or to the left of our line. So again, when it's greater than, we're looking above our line when we're in slope-intercept form. Okay? So that's our solution, that boundary line and that area. Let's look at another one. X plus 2y is less than or equal to 0. Now again, we're going to solve this, or we're going to graph this as if it were an equal sign. And notice that since we have less than or equal to there, we're going to use a solid line for our graph. Now, you can convert this to a slope-intercept form before you graph if you want. I'm going to use an approach that we used before just to remind you of how it goes. We're using our x and y intercepts to graph our line. So our x-intercept occurs when y is 0, and our y-intercept occurs when x is 0. So if I look at the equation instead of the inequality, and I plug in 0 for y, and solve for x, that gives me my x-intercept. Now this is going to backfire a little bit because this is only going to give me 1 point. Because my x-intercept is 0, which means my y-intercept is also 0. So I have the point 0, 0, but I only have 1 point for my graph. So I need another point. Well, what I can do is I can just plug in a point, plug in a value for x. So let's plug in 2 for x and see what comes out for y. Notice I'm using the equation, not the inequality. So I get 2y is equal to negative 2, which means y is equal to negative 1. So I have the point 2, negative 1 on my graph. Okay, so now I can use that to draw a line, and remember, since it's less than or equal to, I'm using a solid line. Now the question is, do I want the points above or below the line? So to find that, I check a point on one side of the line. Let's use one with a 0 in it. Makes it a little bit easier. Let's try 5, 0. So if we plug in 5, 0 to our inequality, is that a solution? Does 5 plus 2 times 0 come out to be less than or equal to 0? It's 5 plus 0 less than or equal to 0. Is 5 plus 0 less than or equal to 0? It's not. So since that point's not a solution to our inequality, that side of the graph is not our solution. This side of the graph is our solution. And again, with a solid line, because we have less than or equal to. Alright, I'd like you to give it a try by graphing the inequality x plus 3y is greater than or equal to negative 1. So pause the video, give that one a shot, and then when you think you got it, we'll go back and see how you did. Alright, so you may have used slope-intercept form. I'm going to use my x and y intercepts to find my line. So to find my x-intercept, I plug in 0 for y, and to find my y-intercept, I plug in 0 for x. If I plug in 0 for y, as an equation, I get x plus 3 times 0 equals negative 1, which means x equals negative 1 because 3 times 0 is 0. So there's my x-intercept at negative 1, 0. That gives me this point right here. Now my y-intercept is when I plug in 0 for x. So I got 0 plus 3y equals negative 1. So 0 plus 3y is just 3y, and dividing by 3 gives me y equals negative 1/3. So I can put a point at 0, negative 1/3. Then I draw my line. And I'm using a solid line because it's greater than or equal to. So which side do I want to shade? Well, a nice easy point to use, since it's not on our boundary line, is 0, 0. Is 0, 0 a solution of our inequality? So if I plug in 0 for x and 0 for y, is that going to be greater than or equal to -1? Well, 0 plus 3 times 0 is just 0. Is 0 greater than or equal to -1? It is. So that means 0, 0 is part of our solution, which means that entire side is part of our solution. So this area up here is our solution area. All right, if you have any questions, feel free to ask. If not, you can move on to your homework.